Hi everyone. For today's lesson, we are going to continue in discussing Chapter 1 Matter. In this lesson, we are going to discuss about limiting reactant. Okay, first let's define the limiting reactant. What is the meaning of limiting reactant? Limiting reactant can be defined as the reactant that is completely consumed in the reaction and limits the amount of product formed. When the limiting reactant is completely consumed, the reaction will stop, which means no more product can be formed. In other words, the reactant that produces the least amount of product, it is called the limiting reactant. Otherwise, the reactants that remains after the reaction over, it is called the excess reactant. Let's say we need to build a few houses. How many complete houses that can be made? From this reaction, we can see that the rooftop has a fewer number than the house body. Thus, the number of rooftop will determine the number of houses that can be made. In this case, the rooftop is called the limiting reactant. In the stoichiometric calculation, it involves limiting reactant. The first step is to identify which reactant is the limiting reactant and then calculate the amount of product based on the limiting reactant available. Let's take a look for an example. Determine the limiting reactant when reacting 16.8 grams of ferrum with 10 grams of H2O. This is the given equation. From the mass given, first, we can calculate the number of mole of each reactant available. The number of mole of ferrum is equals to 0.301 mole and the number of mole of H2O is equals to 0.556 mole. The next step is to identify the limiting reactant. From the given balance equation, we can see that 3 moles of ferrum require 4 moles of H2O. Thus, if 0.301 mole of ferrum available, how many moles of H2O needed? To determine the number of mole of H2O needed, we can use the cross-multiply method. Thus, you will obtain the number of mole of H2O needed that equals to 0.401 mole. The next step is to identify the limiting reactant is by comparing the number of mole of H2O needed and the H2O available. The H2O needed from the calculation is 0.401 mole, while the mole of H2O available is 0.556 mole. Therefore, the mole of H2O available is greater than the mole of H2O needed. Thus, H2O is called the excess reactant. Otherwise, ferrum is the limiting reactant. There are also an alternative answer. If the number of mole of H2O is used to be compared, thus, based on the chemical equation that shows 3 mole of ferrum require 4 mole of water, in comparison of 4 mole of H2O, there must be required 3 mole of ferrum. Therefore, If 0.556 mole of H2O available, so how many mole of ferrum needed? To determine the number of mole of ferrum needed, we can use the cross-multiply method. Thus, it will obtain the number of mole of ferrum needed that equals to 0.417 mole. To determine the limiting reactant, we need to compare the number of mole of ferrum available and the number of mole of ferrum needed. From the calculation, it has obtained the mole of ferrum available that equals to 0.301 mole, while the mole of ferrum needed is greater, which is 0.417 mole. Thus, we can make a conclusion that is ferrum is the limiting reactant, while the H2O is the excess reactant. So we can conclude that when the number of mole available is greater than the number of mole needed, the substance is called excess reactant. When the number of mole available is less than the number of mole needed, the substance is called limiting reactant. Now, let's take a look for another example. By considering this reaction between sulfur and the fluorine gas to form sulfur hexafluoride, if 4 mole of sulfur is react with 10 mole of fluorine, which of the two reactant is the limiting reactant? And then calculate the mass of the excess reactant remain at the end of the reaction. So we have two questions here to answer. First, let's find the limiting reactant. To determine the limiting reactant, first we need to determine the number of mole of the substance available. The number of mole of sulfur available, that is equals to 4 moles, while the number of mole of the fluorine available equals to 10 mole. Based on the equation given, 1 mole of sulfur requires 3 mole of the fluorine. Thus, if we have 4 mole of sulfur reacting, how many mole of fluorine needed? To determine the number of mole of fluorine needed, we can use the cross-multiply method. This calculation will obtain 12 mole of fluorine needed. To determine the limiting reactant, we need to compare the number of mole of fluorine available with the number of mole of fluorine needed. From the calculation, it has obtained the number of mole of fluorine needed that equals to 12 mole, while the number of mole of fluorine available is only 10 mole. Since the number of mole of fluorine available is less than the number of mole of fluorine needed, thus fluorine is the limiting reactant, while the sulfur is an excess reactant. Since sulfur is an excess reactant, the amount of sulfur needed in the reaction can be calculated. Based on the chemical equation, 3 mole of fluorine require 1 mole of sulfur. Thus, since the fluorine is the limiting reactant, it will limit the amount of the sulfur reacted. When we have 10 mole of fluorine available, then how many mole of sulfur that would be reacted? To determine the number of mole of sulfur reacted, we can use the cross-multiply method, and then it will obtain the number of mole of sulfur that equals to 3.33 mole. Since the number of mole of sulfur available that equals to 4 mole, the number of mole of sulfur needed is only 3.33 mole. Thus, we can calculate the number of mole of excess sulfur. From the calculation, it will obtain the excess mole of sulfur that equals to 0.67 mole. From the number of mole, we can convert into mass by multiplying the number of mole with the molar mass. It will obtain the final answer as 21.44 grams. Let's discuss for another example. Substance C is prepared by reacting substance A and B. In the process, 2 mole of A react with 9 mole of B. Now, we need to answer all these three questions. A. Which of the substance is the limiting reactant? B. Calculate the number of moles of C. And C. How much of excess reactant is left at the end of the reaction? Let's answer these questions. Let's start with question A. If the number of mole of A available is equals to 2 mole, the number of mole of B available that equals to 9 mole. From the given balanced chemical equation, we can see that 1 mole of A require 5 mole of B. If there are 2 mole of A available, thus how many mole of B needed? To determine the number of mole of B, we can use the cross-multiplying method, and this will obtain the number of mole of B needed that equals to 10 mole. To determine the limiting reactant, we need to compare the number of mole of B available with the number of mole of B needed. From the calculation, it obtained the number of mole of B needed is equals to 10 mole, while the number of mole of B available is only 9 mole. This value shows that the number of mole of B available is less than the number of mole of B needed. Thus, we can make a conclusion: the B substance is the limiting reactant. Now, let's answer question B. The amount of product formed relies on the amount of B. Thus, from equation that shows 1 mole of A reacted with 5 mole of B. Remember that the limiting reactant limits the amount of the product. Thus, to determine the amount of the product formed, we need to compare with the limiting reactant. In this reaction, B is the limiting reactant. 5 mole of B requires 1 mole of C. Thus, if there are 9 mole of B available, how many moles of C that will produce? To determine the number of mole of C that produce in the reaction, we can use the cross-multiply method and obtain the value with 1.8 mole. Now, let's answer question C. From the given balanced chemical equation, we can see that 5 mole of B requires 1 mole of A. In this reaction, remember that we have determined the limiting reactant. The limiting reactant for this reaction is substance B. So, if we have 9 mole of B, how many moles of A needed? To determine the number of mole of A, we can use the cross-multiply method and it will obtain 1.8 mole of A needed. Now we need to calculate the excess mole of A that remaining after the reaction. We can subtract the number of mole of A available with number of mole of A needed that reacted in the reaction. Thus, it will obtain the number of mole of A in excess that equals to 0.2 mole.